construction today. So getting into what construction innovation is and why it matters to this housing affordability crisis that our nation faces, I want to start by highlighting this figure from the Bureau of Labor Statistics, which tracks productivity in single-family residential construction over the past few decades. So just to level set, when we talk about productivity, we're talking about the ratio of output to hours worked, where output is measured as the number of housing units built, and hours worked refers to the labor input, which of course translates directly to time and money. What's striking about this graph is that productivity today is actually lower than it was in the mid 1980s. This is especially surprising when we consider that we're supposedly in the midst of the fourth industrial revolution, with rapid technological advancements being brought to market across, virtually, well, almost every industry over the past decade. However, as this graph shows, the construction industry hasn't followed this trend. And even if we extend this graph farther back to include close to the past 100 years, there has been minimal growth in single-family residential productivity. So the takeaway here is that there's a significant opportunity. The construction industry is overdue for innovation. The hope, of course, is that by leveraging construction innovations, we improve productivity and we deliver more housing supply for the same labor expense, thereby resulting in more affordable homes. Currently, construction costs account for about 60% of the average sales price of a home, with roughly 40% of those construction costs going directly to labor. So to put that into perspective, home builders are spending about $157,000 on labor alone for each home on average, which equates to about a quarter of the total sales price of a home. Given how substantial this cost is, even modest improvements in productivity through innovative construction methods can significantly impact overall affordability. And we'll explore those methods in the rest of the presentation. I do also want to mention that while we'll mostly be talking about innovative construction methods today, materials, as you can see here, also represent a significant cost relative to the total sales price of a home. And there are tons of really interesting, innovative material alternatives that are out there. OMRO has a lot of experience working with these materials, but again, we're going to focus mostly on building methods today because we think that using a new material is a little bit more straightforward, if it's a one-to-one replacement for something that you're already using compared to moving into like an entirely new construction workflow. We just figured the time is better spent talking about methods. So in this Venn diagram, we have the 5 main innovative construction methods that we see in our work at Ivory Innovations. We spend most of our time researching and tracking innovations across the housing and home building sectors. So while there are some exceptions to this sort of categorization, it's safe to say that these 5 methods represent at least 90% of what's available on the market today in terms of innovations in home building. As you can see, these are organized into the categories of offsite or onsite, and I'll be describing each method individually, and I'll talk a little bit more at the end of the presentation about what the implications are of this offsite versus onsite distinction, as well as how each of these methods compare to one another across a few key metrics. So the first method that we'll discuss is volumetric modular construction. This approach involves constructing entire volumes, modules, or even complete rooms or sections of a building in a factory setting. As you can see from the photo, these prefabricated units are then transported to the construction site where they're usually assembled with a crane. This type of construction, while not super common today, is actually quite versatile. So we see builders using volumetric modular construction for virtually every type of housing, from luxury single family to affordable multifamily. And while its market share is growing, as I mentioned, it still represents a very small percentage of total housing construction. Next up, we have manufactured housing, which is actually a lot more common than most folks realize, representing about 6% of total US housing stock. It's also the leading form of unsubsidized affordable housing in the US. Um, and it's technically a form of volumetric modular construction in that you're building a box in a factory. That's really what volumetric modular means. You're building a 3D section of the home in the factory. The difference between manufactured and modular is that manufactured housing technically adheres to a federal building code known as the HUD code, which requires that the home be permanently affixed to a trailer chassis. The HUD code has the advantage that it allows builders to build to the same home design or floor plan for virtually any community in the country because they don't have to worry about local building codes because the HUD code it supersedes all state and local building codes. However, the HUD code also has the disadvantage of making manufactured housing a less versatile construction method because builders have less flexibility in terms of design and aesthetics. And you'll almost never see manufactured homes used for like multifamily housing or certainly multi-story buildings. I also want to mention that most folks, if you're not like actively working in the manufactured housing space, you're probably more accustomed to hearing the term mobile homes or even trailer homes. Technically, mobile homes or trailer homes, this term refers to this type of housing, but versions of it that were built before 1976. So that HUD code that I mentioned, that was passed in 1976. Before 1976, mobile homes were really common, but they were in this sort of in-between space where the government didn't know how to regulate them. Were they permanent housing? Are they travel? There was no stringent regulation that dictated a higher standard of quality, the same standard that we see for traditional site-built homes. And so in 1976, the government addressed that and basically created a new housing type, which is manufactured housing. So modern manufactured homes are actually very high quality. A lot of the time, they're aesthetically indistinguishable from site-built homes. As you can see in this picture, the home on the right, once they get the foundation finished up, I mean, to my eye, that I wouldn't know looking at that from the street that was a manufactured home. So there's a lot of stigma, and I just wanted to address some of that. So next up, we have panelized or componentized systems. As you might recall from the Venn diagram I showed a couple of minutes ago, this method was positioned in the middle, meaning that it involves both offsite and onsite construction. Essentially, any method that incorporates some amount of factory manufacturing or prefabrication, but doesn't fall into the volumetric modular or manufactured categories is going to fit here. So these systems can range from something as simple and straightforward as a prefabricated roof truss, as you see in the picture on the top middle of the screen, to something that encompasses a lot more components and a lot more trades, like the bathroom pod that you see below that prefabricated roof truss. The renderings that you see here, with the exception of that roof truss, are from a California-based company called Capsule. And they do everything from wall panels to the bathroom pod to the bathroom and laundry pod. So there's a lot of flexibility and variability in this construction method. Second to last, we have mobile automated equipment and robotics. This is a really interesting emerging space. So while offsite construction, including the methods that we've discussed so far, has actually been around for over a century. A lot of folks are familiar with the Sears kit homes that were popular in the 1920s and 30s. This method and robotics as a field is obviously a lot newer. So typically, robots in the home building space are designed to perform a specific task or trade. So in the photo, there's a drywall finishing robot from a company called Canvas. And this, as you might guess, automates the process of finishing drywall. These robots can technically be used in any construction setting, but they're going to add the most efficiency to your work when you have larger projects and also a large volume of projects, because the efficiency gains of replacing a human with a robot are going to be highest when you have enough work that you can basically have that robot working for you around the clock. Anytime that that robot is not actively doing work for you, you're kind of losing money on it. The last method that we'll cover is 3D printing. 3D printers automate the placement of concrete, typically using either a robotic arm, as shown in the photo, or a gantry system, which is a frame-like structure that moves the printing nozzle along fixed tracks, similar to what you've seen if you've ever looked at like a desktop 3D printer. Currently, these printers are not yet efficient for constructing taller multi-story buildings, so they're mainly used for single-family homes. A notable example of this technology in action is Apis Core, which actually produces 3D printed home building components for developers to purchase. They're based in Melbourne, Florida, and this photo here showcases one of their 3D printers in operation. Before I pass the mic to Amro to talk about the process of actually implementing innovative construction solutions, I'm just going to show an 8-minute clip from a longer video that we produced during the 2023 Innovative Housing Showcase, which is presented by HUD and the National Association of Home Builders in DC on the National Mall. So during the showcase, builders and suppliers from all over the country come together to exhibit their products on the mall. And we took the opportunity to partner with HUD and NAHB to put together a webinar on offsite construction, including some short interviews with a number of the folks who were exhibiting. So these are some of those interviews.
Hi there, I'm Brent. I'm with Bot Built. We're originally based in North Carolina, but we're here today in our nation's capital, brought out here by Ivory Innovations, the NAHB, and HUD. And what we do is we build homes with robots, but what we really do is use AI and computer vision technology to enable humans to build safer, build faster, and build more cost effectively so that we can help end the housing crisis. Builders that come to us know that what they're getting is built with robotic precision. They also know that their framers will have a safer life building with our housing components, built right here in America in factories where we can put robots near you for whatever you may need right away. Here at Bot Built, we enable humans by giving them robotic leverage, and we're building the future together.
Hi, my name is Gene Edelman. I'm co-founder of Azure Printed Homes. When people talk about housing and climate, it's always followed by the word crisis. We're going to solve both of these. This 3D printed home can be printed in 1 day and finished in the next 4 to 5 days. And it's printed from recycled plastic. So for every one of these homes, we use equivalent of over 100,000 empty water bottles to make. It's very scalable. It can come to any community here in America. And we manufacture them in our factory. It's very light. It gets on a flatbed truck and can be delivered literally anywhere. So we're 30% less expensive, 70% faster, and with a positive environmental impact.
Good morning, everybody. My name is Ben Kaiser, and we just traveled here from Portland, Oregon with our idea, which is Path House. And Path House is a modular mass timber manufacturing idea to essentially take housing and use industrialized construction to create up to 50,000 housing units a year out of a facility that's very advanced in our great state of Oregon. And the way we're going to achieve those high numbers, that high volume, representing approximately 200 million board feet per year, is by essentially assembling all of the MEP, mechanical, electrical, and plumbing components of the home directly in the bottom 10 inches. So what we're calling this is the smart cassette. And so everything is located down in the smart cassette. That's the electrical distribution, that's the plumbing distribution, that's the HVAC, heating, ventilation, cooling distribution. And in that way, we'll treat home manufacturing much like the whole automobile industry has done, and assemble in an OEM facility It's much like a dashboard going into a Tesla, we're doing the smart cassette into housing. And it's under that paradigm, we can create up to 50,000 housing units per year. And then the ancillary benefits of that is, of course, utilization of mass timber, which is something we've been working at it for about 9 years now. We're pretty much leaders in the United States. We've built some of the tallest buildings in the country, and we've realized that this is the best material to address the challenges in our country right now, twofold. One, housing crisis. The entire country has a dearth of housing, and we're all made aware of that every day in our cities. And two, of course, the advancing climate change issues. Much of what we're seeing here in DC, which is unfortunate, the smoke coming down from Nova Scotia. Canada should not be burning in June, everybody, and we all know that. And so we're doing our best part in the PathHouse team to capture as much carbon as we can into these modular housing units. So it's such a pleasure to be here at HUD's invitation with Secretary Fudge, and we're just appreciative that we're a part of this great assembly of innovators, much like ourselves, up and down the mall here in DC.
I'm Brian Stark with Steel and Spark. We have a sustainable off-grid housing unit behind us, so let's go take a look at it. So this is our SparkBox 2A, meaning that's an accessible unit. It's one of the only accessible units that we've seen on the market, so fully wheelchair accessible. It also is fully off-grid. So these boxes are dropped into your backyard without any permitting required, a long permitting process. We're in 400 square feet with 2 shipping containers, and this unit is fully off-grid with 25 kilowatt hours of Discover battery. This allows you to drop housing quickly in your backyard. It sets up in 1 day. There's no utility connections to it, there's no sewer connections, there's 1,250 gallons of fresh water storage. The toilet is incinerating. All the water is stored into a gray water tank from the shower and the sink, and that gray water tank is 330 gallons, and you can use that for irrigation, any of your plants in the yard. The goal here is really to get housing out quickly and to be able to serve certain populations where I have an aging parent that I want close by, generational living. I have a child with special needs that I want to have independent living, or I just want to make some extra money and put this in the backyard and rent it out. Maybe I have a college kid that's come home that I really don't want in the house anymore. So those are kind of the market that we're really looking at to increase the amount of housing that's out there.
We are a net zero sustainable modular homes. We're trying to bring aerospace and automotive technology to construction. A Tesla is built every 43 seconds. We want to bring the same pace to modular homes. Our country has serious shortage of homes, and net zero modular homes can not only fix that shortage but also address the energy crisis. Our modular homes are not only faster to build, affordable, but they're also energy efficient and mold and pest resistant. So if you're in the market for bringing high quality homes quicker and affordably, you should contact Remo Homes. Thank you.
My biggest takeaway from walking the mall and checking out all these different exhibits is the fact that there's a ton of passion and energy in the industry. And there's a lot of people really looking at how they can do things differently, and not just for the sake of doing it differently, but truly to advance how we deliver house and home. I think one of the things I want to bring up here is the fact that the industry's got a bad rap, right? Everybody says we're not investing in enough innovation, but if you're out here walking this space and meeting these founders and the companies that are out here promoting these kind of technologies, I think you'll find that's very wrong. Of course, we can't change what's happened in the industry over generations, overnight, but what we see here is a demonstration that we're making promising steps.
Okay, by the way, we will be sharing our YouTube link at the end of today's session where you can see the full version of that video if you're interested. But with that, here is Amro to discuss how you can think about putting some of these innovations into practice.
Hi there, I'm Brent. I'm with
Thank you, Chad. So when it comes to implementing innovations in construction and design, there are 4 key considerations that we keep looking at while evaluating these companies and products. As Chad mentioned earlier, construction costs are skyrocketing, which is reflected by the increasing home values, and it's not, our income increase is not matching that. So cost reduction is usually one of the first points that we look at and evaluate when looking at and exploring an innovative idea. So The first point is cost reduction or cost reduction potential. This point includes all the ways that construction costs could be reduced, such as using the new materials with the same performance characteristics as specified in your project, but it's a little bit cheaper. It could also mean the reduction in construction timeline, therefore reducing the overall construction cost. Or when, for example, using modular, you're doing it in a controlled environment that will reduce the risk, therefore reduce your overall construction cost. The second point that we look at, its applicability and implementation. And this point addresses the concerns and capabilities of the contractors performing the jobs on site or off site. It is crucial to discuss and evaluate these innovative ideas with the project team and project contractor in early stages of the project to avoid any future implementation issues, as many of these innovations might alter your project timeline and schedule, require a new construction project, or require you to make some design changes in these projects. The third point, talking about acceptance and regulations, this covers the codes that are governing your project, and it's different from one locality to the other, from one state to the other. Some of these innovations are harder to be implemented in some localities or states because the lack of regulations to support them. And I'm just going to give you one example that we recently had here in Utah. For example, until early 2024, Utah did not have a state code, a state modular code. And the decisions regarding the plan review of the modular components or the inspections of the modular components in the factories, which are crucial to the success of the modular construction process, were left to local jurisdictions, which created a lot of problems because a lot of these peoples don't have the knowledge and enough experience in modular construction. In early 2024, the state legislature passed a code to streamline these processes with the ability to do third-party plan review for the modular components and also third-party factory inspections. Obviously, there are some regulations that governs how these third-party inspections and plan reviews are done. There has to be a process of approving these entities by the state. But with that, we're streamlining the entire process of the plan review and inspections, which makes it easier for developers to use the modular process or modular construction method in their projects. Moving to the last point on this slide, which is sustainability. While we're all working to promote housing affordability through innovations, we also look at sustainability aspects. There are new materials in the market that have similar performance characteristics to existing ones, but are more sustainable. I'm going to be mentioning one of these materials that we're exploring in the next few slides. So in the next few slides, I will briefly discuss two projects that we're working on and mention why we're thinking about these innovative ideas in these specific projects. So the first project or the first case study, it's about a project called Innovation Park at Vista Station. This is an apartment complex in a fast-growing neighborhood in Draper City, which is located to the south of Salt Lake City. This project will include approximately 200 units and focused on young professionals due to the proximity to major tech hubs in Utah, such as Silicon Slopes. So in this project, we're looking at using modular construction and why, or a volumetric modular construction. Why we're choosing modular construction in this project. So in modular construction, consistency in unit size, specifications, and designs is necessary for a smooth and efficient module manufacturing process. The Vista Station project includes high unit type repetition. Approximately 90% of these units in the project are studios and one-bedrooms, and only 10% of these units are two-bedroom units. As you can see in the plan shared in the slide in front of you, every color shows a different module design, but that doesn't mean that it's a unique module, because there are only two sizes of modules that we are using in this project. And the different colors could reflect some interior changes in these modules. In the next slide, I will be sharing the few unit types that we used in this project to complete a 200 unit project. So as I discussed, there are 3 unit types: studio, 1 bedroom, and 2 bedrooms, and there are only 2 module sizes that are used in this project to assemble 200 units. Starting with the units on the far left side of the slide, we have our 2 base modules, which are on the top, the 36 by 13 feet, and on the bottom is the 30 by 13 feet modules, which are also our studio designs in this project. In the 2 plans in the center of the slide, we are combining 2 of the 30 by 13 modules to create a 1 bedroom unit type and 2 bedroom unit type. The plan on the far left side of the slide shows a second 2 bedroom unit design that we have in this project, and it uses 2 36 by 13 modules combined with each other to create that unit. So now I'm going to be discussing about like how the modular construction process is different from the traditional stick build. With traditional stick build, you know, it's a linear process. You have to do the utilities, build your foundation, and then start building your apartments on top of that, and then do the finishing. In the modular process, it's a little bit different. On-site work, meaning utilities and foundation works, are happening at the same time as the modules are being built in a factory somewhere, might be near or far away from the project site. Then after that, we ship these modules to the project site where they're stored, and then we will have installation of these modules inside. Installation is usually a quick step, and then we move to finishing up these modules. So it depends on the manufacturer facility that you're working with. Some of these modules might come fully finished from the exterior, some of them not. We also need to make sure that we're connecting the utilities between these modules and connecting these utilities to the site infrastructure as well. So because of the high repetition rate, could you, Chad, go back to the same slide? Yeah. So because of the high repetition rate, a manufacturing facility could actually produce these modules at a much faster pace. So the modules in this project will probably be manufactured in approximately 10 to 12 weeks. On-site installation will take approximately a month to a month and a half. With this fast pace of construction in this project, we will be able to finish this project in 13 to 16 months if we are using modular construction. If we're using a traditional stick build method, it will take up to 28 months for completion. Now we're going to talk about another project or another case study where we are trying to implement a new material. This project is called Innovation Park at Liberty Wells. This is a unique project because it includes the adaptive free use of an existing gym building that was built in 1950, and it will be turned into a 30-unit apartment complex. And it will also include the construction of 36 townhomes just to the south of the Salt Lake City downtown core. As discussed in previous slides, identifying innovations in an early stage of the design is crucial to implementing most of these innovations successfully. When we decided to look for innovative ideas for this project, we had already passed the concept design stage. So we started looking at materials that would not alter or change the existing concept design and delay the project timeline. So for this project, we identified a wood fiber insulation material that won't affect the project design or timeline. This material provides similar thermal insulation performance to commonly used insulation materials like fiberglass blown-in or rock wall bats. It also provides better sound insulation than these materials. This material is also more sustainable than other insulation materials and is cost competitive in the insulation material markets. And with that, I will be turning it back to Chad to conclude this presentation. Thank you.
Thanks, Amro. This is our last slide before we open the floor to you all for questions. So this chart just really provides an overview of the 5 types of innovation that we've talked about today. This is definitely a little bit generalized, so take it with a grain of salt, but we thought it would be helpful for anyone who is just entering this space and is new to learning about these different construction methods. So the metrics that we compare each of these methods across are number of trades impacted, ease of implementation, and versatility. As you'd probably guess, green means good, red means bad, and yellow is kind of neutral or in the middle. So starting with number of trades impacted, what we're thinking about here is efficiency. The construction method that eliminates or reduces the need for on-site work for the largest number of trades is theoretically going to offer the greatest potential for cost savings. For example, with manufactured and volumetric modular construction, the majority of the construction process takes place in the factory, so almost every trade is impacted. When you're doing work in a factory, there's huge potential for cost savings just because factories are better at making things than we are, at least right now, on a job site. And that's just because factories get economies of scale. They can order much larger volumes of materials. That leads to savings. They're building in a controlled factory environment. That leads to savings. They're not impacted by changes in weather or seasonal variation. You can have workers who are highly specialized on a specific task or element of the building process. And then you can use machinery, heavy machinery, automation, and things that are just currently not really feasible to bring to a job site. Ease of implementation is the next category, which I alluded to earlier when I was talking about this off-site versus on-site distinction. And this is what it sounds like. It's really just measuring how feasible it would be for somebody who is accustomed to traditional construction workflows, stick building, how easy it would be for somebody to transition to one of these building methods. Finally, versatility is probably the broadest of the 3 metrics that we show here. And the idea is really, if you chose one of your projects at random, how likely is each of these construction methods to be able to be utilized in that project? So for example, manufactured housing, while it's great at single family detached, isn't going to work for almost any multifamily projects. And there can be some design limitations like roof pitch and architectural style that might make it, a suboptimal fit for certain neighborhoods or communities. Another example, 3D printing can technically be used for multifamily, but right now the technology is just not efficient for building taller multi-story buildings. And you're also limited to the use of concrete as like the main structural material with 3D printing. And so that's another limitation that negatively impacts versatility. On the far right column, we also listed out some other considerations. So I'll just summarize these quickly. For manufactured housing, I talked about the stigma a little bit. We've all seen the portrayals of trailer parks or mobile homes in popular culture. These are really not in line with what modern manufactured homes look like. They're high quality. They appreciate similarly to site-built homes when they're titled as real property. But that stigma does impact demand in some communities. Volumetric modular, as Amro discussed, is best for multifamily, but can be limited in terms of feasibility just by building code and permitting challenges. Panelized or componentized systems there's such a wide range, it's tough to generalize, but usually there's some trade-off between the amount of prefabrication and thus the amount of efficiency that you're getting from a system and the amount of potential for customization that you have in the finished product. Mobile automated equipment and robotics, as I mentioned, there's a high upfront cost. You're going to need a large volume of projects in order to make that initial investment worthwhile. And then I talked about some of the limitations of 3D printing in terms of aesthetics and the limitation of only being able to use concrete. The last point that I want to leave you all with is that with all these methods, you may have to try it a few times before you get to a point where you're realizing the savings that they offer. So these systems can definitely offer savings as well as other advantages, as Amro mentioned. But as with anything new, there's going to be a learning curve. So there are definitely big benefits to be had in the long term, but we recommend that you budget in some time and resources on the first few projects, because you're likely going to run into snags. There might be complications. You're getting accustomed to a new workflow. Your partners are getting accustomed to that new workflow. And it just might take a few iterations before you really start getting into like a seamless efficiency. So that's all for the main part of our presentation. I do want to mention that at the very end, I just have a few more slides that are a couple of links and resources that you all might be interested in to move forward. But I think, Deanna, let me know, but I think maybe we get into questions now, and then I'll just share those slides at the very end.
Perfect. Yes, I will read you off those questions and then you can share those resources. If anyone has any questions, please feel free to drop those in the chat, or you can use that hand raise tool and we can call on you. Our first question for you all, in terms of modular and offsite construction, what innovations are there in the last mile problem? The cost to transport requires factories to be located in relative proximity to final destination. I think of cars as a distribution example. Container ship, rail car, 18-wheeler.
Yeah, no, that's a really good question. I'll take a stab, and then Amro, if you want to jump in, feel free. So first off, there is actually, I guess the limit of how far a supplier or a factory can be from the actual project site is actually much larger than a lot of folks think. So I was involved in a series of case studies of folks who were developing with manufactured housing. And what we found was that as long as the factory is within 500 miles, the transportation cost is, as long as you're not talking about like a finished section or a finished module that is like silly oversized dimensions. I mean, most of these units are designed and manufactured by the factory with the understanding that they will be trucked to their end destination. And so with that in mind, they're made so that they're not oversized and they can be transported efficiently. So 500 miles is quite a large radius. That said, what we've seen over the past few years has been a fairly significant transition to more decentralized factory networks. Anyone who's been following the modular space would have heard about Katerra, which was like this multi-billion-dollar valued startup that claimed that they were going to totally revolutionize the construction industry, got a ton of venture capital investment, developed like a Tesla-esque mega factory, and then went out of business. So the industry has sort of responded to that by saying, okay, maybe we start off by just building factories that aren't the most technologically advanced, but because of that, the capital expenditure required to get the factory operating is lower. You can site factories closer to the end destinations by building more of them instead of just having one central factory that's shipping everywhere. So I think the industry is definitely thinking about that problem. I hope that answers the question. Amro, anything to add?
Yeah, just to add a little bit. So as Chad mentioned, we're seeing a lot more smaller factories that are distributed across the states, which will help with this transportation issue. Or I wouldn't call it an issue. It's just part of the modular process. But I just want to mention one example, which is the project that we're working on right now, and we're exploring modular construction in. We've received some like very rough estimates, and based on these estimates, the shipping cost will be approximately, like, it will be a few bucks per square foot addition. And by that, we're talking about like 3% of your modular construction cost, factory construction cost. So it doesn't add up like 10-15% to your project. No, it adds up just a few bucks per square foot for the transportation, and we're talking about like a 400-mile radius, around 400 to 500-mile radius.
Very good. Next question for you guys. Do you see home construction becoming globalized?
I would say, do I see home construction? I mean, there are definitely material suppliers that are located outside of the US. But obviously, I mean, so 500 miles is the limitation in terms of proximity to the job site. Like, China is not within. I mean, we've seen some manufacturers, even in the modular space, who are taking like the flat pack approach that you'll see with like IKEA furniture, where everything is broken down. It's packed into a flat, thin profile box. There are a few manufacturers that are trying to do that sort of approach with modular construction. So they're building in a factory in China, and they're getting, all of the cost savings and labor savings that comes with. And then they're shipping these flat packed, modules to the US, and then they're assembled in the US. I would say, though, that generally in the offsite construction space, and I can't speak for like, how many of your smaller electrical components or smaller HVAC or plumbing components. I mean, I'm sure a significant portion of that market manufactures in Asia. But for the bigger, your modular boxes, your larger components, most of what we see is manufactured in the US.
I can add something here. So right now, the stick-built process, the traditionally stick-built process, is highly localized, because your workers have to be on site, your material have to be on site, and the availability of these materials and workers will drastically affect your construction process. What we are seeing right now with some of these innovations that Chad mentioned, like 3D printing, like panelized systems or modular systems, we're talking about decentralizing this process. If you don't have work, for example, when we're talking about a remote town here in Utah, where they don't have enough labor to build homes, well, you can contact a manufacturing facility in Colorado where they have the workforce to do these homes. You do them in a modular way, and then you ship them to Utah, and you will need minimal on-site work to install these, and you have a home. So it is becoming decentralized, but on a national level, where you can go to surrounding states, surrounding cities, and counties if you don't have the availability of the materials and the workforce.
Very good. And for those of you with your hand raised, I'm going to get the chat questions first, and then I'll come back to you. Our next question: how do modulars tend to hold up against natural weather phenomena like tornadoes, hurricanes, or excessive heat?
So, Chad, do you want me to answer?
Yeah. Why don't you take it first, Amra?
Yeah. So the modular components, or any modular project, is required to be built to the same standard as any other stick-built building. So they will follow the same building codes, the same regulations that the state has, or on a federal level, we're talking about the IBC code, IRC code. the mechanical, electrical, safety codes. And then when it comes to snow loads, wind loads, these are specific in each area. For example, here in Utah, the Salt Lake Valley is different from the Wasatch Back, which is up in the mountains. So each module or each modular building will have to meet the same building codes and criteria that any traditional built building need to follow.
Yeah, I'll just add, so Amra is talking about modular, as we discussed, and as you can see on the screen, so volumetric modular and manufactured, two different building types. They're both built in a factory. Manufactured housing is built to the HUD code, so it's not the IRC, IBC. It's the HUD code. It preempts all state and local building codes, and that's a performance-based code. So instead of being like prescriptive and saying, you know, this number of, I don't know, nails to joist, I'm obviously not somebody who's actively working in the development space, but instead of specifically prescribing materials and standards for connecting those materials, the HUD code says, you know, the home must be able to withstand this speed of wind for this duration of time. It must be able to withstand this sort of roof load for this duration of time. So I guess the short answer is that these homes perform similarly, if not better, than site-built homes in terms of natural disasters.
Next question. Do the materials expand over time like older home structures?
Amra, I think.
So with modular construction, it's built using this, like mostly using either the wood lumber, like when we use, like what we used in stick built, like 2x4s, 2x6s, trusses, TGI joists, OSB sheets for sheathing. Some of them uses light gauge steel. So it depends on the product, but at the end of the day, these products are going to be affected by these weather conditions. So it will react like any other building that is built today in the market.
Next question. How are the materials replaced? Is there ever need for home improvement?
I can answer that as well. So like any other building, with time, you would need to replace some of these components. For example, your roofing system, if you have a pitched roof, in 10 to 20 years, you would need to replace it. And that is the same for modular construction. At the end of the day, it's a building that is built in a different process, but using the same materials that you will use to build traditionally. So it will react to time and nature the same way that other buildings would.
Next question. Is there feedback on whether or not manufactured homes bring down the value of traditionally built homes, or do traditional homes help uphold the value in the overall neighborhood?
Yeah, I can answer that. There's no data to suggest that siting, you know, if you're talking about like an infill development, you've got an unbuilt lot in a neighborhood that's mostly built, mostly site-built housing, putting a manufactured home on that lot, there is no reason whatsoever to believe that that would negatively impact the surrounding lots values. And I mean, what we see, actually, there have been, you know, very rigorous studies looking at the appreciation profiles of manufactured homes that are titled as real property. And they appreciate similarly to site-built homes. The stigma that's associated with manufactured housing is mostly, well, as I mentioned, there's pop culture, there's TV shows like Trailer Park Boys, which aren't helping things. But then there's also like I mean, it's really just the stigma that's associated with affordable housing generally. Manufactured homes are generally affordable, and people tend to oppose that for various reasons. But the truth is that there's nothing about the construction method itself that, you know, means less appreciation of the property or less appreciation of the surrounding property.
Very good. Next question. How do we ensure that the decrease in input cost or production cost actually translates to a cheaper housing product on the market for consumers? Housing is a relatively inelastic good. So what stops a large-scale developer that can produce a cheaper housing product from actually selling it at a lower price point in the market? I am thinking about the income to housing cost ratio graph.
Yeah, I can take that's a good question. I'll take a stab at it. You know, it sounds like this is somebody who knows their economics. I think if you think of it like, you know, if you think of your housing product as a widget and you're manufacturing widgets, if you're saving costs on, you know, the cost of manufacturing those widgets, well, you've got two options. You can either sell more widgets for a cheaper cost, and you're able to sell more because you have a lower cost than your competitors, or you can sell at the same cost as your competitors and sell fewer widgets, but, you know, in theory, maybe make a comparable profit that way. So you know, the hope is that we don't know. I guess the short answer is that, yeah, like when you're getting cost savings, you can decide I'm either going to sell a cheaper home and pass those savings on to the consumer, and I'm going to be more competitive in the market because I'm coming in at a better price point. I'm going to sell more homes and I'm going to make my money that way. Or you can do the other strategy that I mentioned. And yeah, I mean, that's a decision that, you know, folks are going to make. Amra, do you have anything to add?
No, it's basically what you just described, Chad, with lower construction cost and faster process. We will end up with more available homes for sale. That will drive costs down because it's supply and demand at the end of the day. And if there are two large developers that are doing the same thing, people will go to the cheaper choice, obviously, if like location and quality is the same in both situations.
Next question. With the modular project in Draper, was the project designed by a local architect or the modular company?
So the current concept design that I shared the plan from was done by a company called VBC, or Volumetric Building Companies. This company is based in Philadelphia. They have another manufacturing facility in California as well. And they're vertically integrated, so they have the design and they do the design, the manufacturing, the shipping, and they help with the installation as well. There are other companies that only does the manufacturing. There are other companies that they deal with specific architects over and over, so it makes the coordination and the engineering work much easier if you're working with these specific architects and engineering firms that they recommend. But at the end of the day, any architect could design a modular building. There are just very specific things that needs to be taken into consideration, such as height, maximum width, maximum length. But it's like it doesn't require an additional certification or needed for the architects to be able to design modular construction.
And it looks like this is our last question in the chat box over panelized systems. What US-based companies are using LiDAR scan measurements of an existing home for retrofit renovation and factory building panel systems based on the 3D digital twin of the existing home?
Omro, I mean, I have an idea. I don't know if I can answer this one off the top of my head.
I'm trying to think about it. So if you have an answer, go for it.
Okay. I guess my answer, this is a bit of a cop out, but one of the resources that I was going to share, we have a database. It's got over 500 builders, suppliers, innovative organizations in the housing space. We maintain it regularly. You can find organizations that are in your area using this database. I would look at the database to try to get an answer to that question. I think that Bot Built, which was featured in the video from DC that we showed, I think that they're doing something like what was described. It's the best I got. Sorry.
Wonderful. Well, it looks like that was the last question. I don't see anyone with their hand raised, Chad. So if you want to share any more resources.
Great. Yeah, so this database, as I mentioned, over 500 builders, material suppliers, innovative organizations from across the nation. If you are interested in starting a conversation around utilizing one of the methods or materials that Amra and I talked about today, strongly recommend starting with this database. You can look at your state or your region in particular, find folks close to you. Amro and I are happy to help make connections if you're interested, but most of these folks are, you all are developers, you're the people they want to talk to. As I mentioned, that video that I showed, that was a clip from a 40-minute video called What is Offsite Construction? That's on our YouTube page, youtube.com/@Ivory-Innovations. We have dozens of 3 to 5 minute profiles on innovative organizations in the housing sphere. They're easy to watch. They're produced well. We don't produce them. We go to some folks that specialize in film, so they're good. So I recommend taking a look at those. We don't do, so Ivory Innovations itself doesn't do a ton of work in manufactured housing. We're more focused on volumetric modular. Manufactured housing, while it has huge potential for cost savings and is today, it's an excellent product. I actually think of the methods that we talked about. It's if you're a single family developer that wants to build more affordable homes, this is the strategy that I would recommend. But manufactured housing has been around for a long time, so it's less a part of our focus at Ivory Innovations. But I mentioned the papers that I worked on at Harvard over the past couple of years. These are links to each of these papers. Diana, will they have access to the slides so that they can
Yes, I've got a couple questions about that already. You guys will receive a copy of the recording. You will get their PowerPoint presentation, and I will also make sure that I include Chad and Amro's contact information. If you want their email address, that will be included as well. So yes, you will get all those things.
Perfect. Yeah, so these links will be in that. These are just short summaries of the longer papers. If you want to read the full 20 or 30 page report, the link is in the short summary. But start with the short summary, see if you're interested, and then here's our emails, which Diana will also be sharing. I just want to reiterate that this has been great. I mean, you all are doing exactly the type of work that our organization exists to support. So we were super happy and excited to get to talk to you all. I'm glad that there were questions. It seems like folks were a little bit interested. Amro and I would love to talk more. If you have any specific questions or want to learn more, please reach out to us. And of course, we want to thank Angela, Diana, and then Cass and the rest of the team at Freddie Mac and Spark, who made this program and today's presentation possible. So thank you all again. That's it.
Thank you so much for being here, Chad and Almero. That was great information. And like I said, everyone, you will be receiving those items. Also, please, please, please take that survey. That survey is in the chat box. It's also going to be in that email that I send you with the presentation link and the recording. So please don't forget to take that. With that, everyone, have a great afternoon, and thank you for being with us today. Bye, everyone.